By the end of this lesson, students will be able to write the general structure for carboxylic acids, give the IUPAC names of the carboxylic acids, state the reactions that are used to prepare carboxylic acids, compare the acidity of a carboxylic acid with that of alcohol and phenol, predict the acidity of a substituted carboxylic acid. The general structure of a carboxylic acid is RCOOH. The carboxyl group is the functional group. Click on the Carboxylic Acids button to see some examples and their names. Give the IUPAC names of the carboxylic acids shown. Click the boxes below the structural formulae to check your answers. Summary. The general structure of a carboxylic acid is RCOOH. The carboxyl group is the functional group. Primary alcohols and aldehydes can be oxidized to carboxylic acids by reacting them with acidified potassium dichromate 6 or potassium manganate 7 under reflux. Click the Heat button. Click on Example 1 and Example 2. Carboxylic acids can be prepared by hydrolysis of nitriles with acid or base. Click on Acidic hydrolysis. Click Example to view the equation for the acidic hydrolysis of ethane nitrile. Now, click on Basic hydrolysis. Click Example to view the equation for the basic hydrolysis of ethane nitrile. Summary. Primary alcohols and aldehydes can be oxidized to the corresponding carboxylic acids by reacting them with acidified potassium dichromate 6 or potassium manganate 7 under reflux. Carboxylic acids can be prepared by the hydrolysis of nitriles with an acid or a base. Unlike hydrochloric acid and sulfuric acid, which are strong acids, carboxylic acid is a weak acid that does not dissociate completely in water. Let us compare the acidity of carboxylic acid with that of phenol and cyclohexanol. Click on button A, B, and C to add aqueous sodium hydroxide to each of the compounds. on play button and then on D, E and F to add aqueous sodium carbonate to each of the compounds. Note that phenol is not acidic enough to react with carbonates or hydrogen carbonates. Drag and drop the boxes to show the correct order of acidity of cyclohexanol, phenol, and benzoic acid. Click on Equation. Click RCOO-. Carboxylic acid is a stronger acid than phenol because the carboxylate ion formed is stabilized by resonance. The pKa values of some typical carboxylic acids are listed in the table. Why are ethanoic acid and butanoic acid weaker than methanoic acid? Click on ethanoic acid. Answer: the alkyl groups in ethanoic acid and butanoic acid are electron donating and hence destabilize the carboxylate ions formed. What will the pKa value be if a hydrogen atom in ethanoic acid is substituted with chlorine? Click chloroethanoic acid. Answer: it will be less than 4.76 as it is a stronger acid than ethanoic acid. Chlorine is electron withdrawing and hence stabilizes the carboxylate ion formed. What will happen to the pKa value if the chlorine atom is substituted with a fluorine atom? Answer: the pKa will be less than 2.86 as fluorine is more electronegative than chlorine. Hence, fluorine has a greater electron withdrawing effect. Summary: carboxylic acids are weak acids that do not dissociate completely in water. The order of increasing acidity is as follows. The presence of an electron-donating group decreases the acidity of a carboxylic acid. The presence of an electron-withdrawing group increases the acidity of a carboxylic acid. A carboxylic acid reacts with reactive metals, alkalis, and carbonates or hydrogen carbonates to form salts.